Does.
Yeah, that's what I'm saying.
I think I have sent to all three of you.
Okay, okay, fine.
What the background?
Yeah.
Let me change.
I think Ruhi, are you able to let the people in?
Yes, sir. I'm just doing the live streaming. It's just got live stream. Now I'm just taking the guest.
It's already 9 minutes late, 10
Yeah,
minutes late.
it does.
It should not happen. People should not withdraw from the, waiting for 10 minutes.
They are joining.
Hey, Alok, when did you send?
Even I'm not
Just,
getting.
Got it, got it.
Just when you mentioned,
Yes, just got it.
अपना तो अब तक नहीं आया.
तो मुंबई में थोड़ा टाइम
ठीक
लगता
है
है.
यार अभी हाँ.
No, I think people
I
are,
got it.
yeah, people are coming in. I think
Let's
all of you can just, if you can just make yourself
Yeah,
mute.
Shirke, you did not get it.
मैं करता हूँ ना, while going I will do it.
ठीक है, ठीक है, ठीक है.
Don't worry.
Okay.
Yeah, is it okay now? I think I have got it.
Yes, yeah.
Yes, yes.
Yeah.
I think Rohi, without wasting any time, you can start. By the time I think we introduce yourself
Okay, sir.
and others, I think the people will be joining. Yeah, please go ahead.
Okay, sir. Good evening, all. I welcome you all for our special lecture 33 series. Today we have Engineer Vinay Gupta, Engineer Umesh Rajasirke, and Engineer Alok Bhaumik with us. They will be speaking on making of bridge engineer. Now, I would like to introduce our moderator for the event, Engineer V.N. Hegde. Engineer V.N. Hegde, presently structural consultant and Decon Complete Solutions and former CEO, Stoop Consultant and former executive director of Gammon, a senior professional with a rich experience of over 3.5 decades in construction sector in the areas of design management, technical management, site management, project management, and contract management of highways, bridges, energy structures like chimneys and cooling towers, environmental, marine, and hydraulic structures. He is a recipient of around 9 national recognitions in addition to an international prize, various institutions like IRC, ICI, NDRF, IBC, and IABSC. He has more than 140 publications to his credit and is a member of various IRC and BIS committees. He is also a member of TG 10.1 of Federation International Louis Vuitton, which is a special task group working on FIB Model Code 2020. Apart from being on technical board of ICI and academic board of SPSC, Sardar Patel of College of Engineering is a fellow of Indian National Academy of Engineering. With this introduction, I would like to hand over the session to Engineer V.N. Hegde. Over to you, sir.
Thank you, Rohi, for that nice introduction. If you can just let the screen to me now, if you just come out yourself, I will just go to this presentation of mine without wasting any time. Are you able to see my screen basically?
Yes.
Yes, yes. Okay, fine. So, welcome to this special session of this IIB lecture number 33, Making of the Bridge Engineers, a panel discussion. In fact, we are having. We have some outstanding bridge engineers among us today, and Vinay Gupta, Engineer Raj Shirke, as well as Mr. Alok Bhaumik. And the topic basically is making of bridge engineers. And first of all, I thought I'll just give an introduction to this particular panel discussion today before going into our panel discussion. Just to understand who are the good bridge engineers, and once we understand what are the bridge engineers, who are the engineers, bridge engineers who are par excellence, then having looked at the characteristics of those bridge engineers or the attributes of these bridge engineers, we'll be able to really discuss on that. also the experience of our own good bridge engineers like Mr. Vinay Gupta, Raj Shirke, as well as Alok Bhamik, you can hear, and we can start the panel discussion. So I'll give you a 10 minutes introduction to the topic. And story of the making of good bridge engineers, in my opinion, starts with the Thomas Telford. Way back in 1757, he was during that 1757 and 1834, he really, revolutionized the bridge engineering, especially in the form of the aesthetic bridges. His bridge, namely Kregalase Bridge, and also the, another bridge, the suspension bridge, which is very famous. That is the Menai suspension bridge, which is called. And he was such a prolific designer and construction of the bridges at that era. He was known as a colossal of roads, pun intended for the colossal of actually RHODES, that is the space of the place it is called. If you look at it, he was a founder, the founder president of the Institution of Civil Engineers of UK, and till his death for 14 years, he was the president of that. Then comes the Gustav of Eiffel, of the Eiffel Tower fame. And he constructed and designed some wonderful bridges all over Europe, and including that famous bridge, which is called a bridge in Portugal, on the river Douro. And he was hailed to be, at that particular point of time, as the leading engineers of the time in an exposition universally in 1878. He was a French engineer and also an architect. Then comes Roebling, and Roebling was a very passionate towards constructing and designing the suspension bridges. All of you are aware of it. During his time, he constructed and designed numerous suspension bridges which were holding the world record. Some of them are the Brooklyn Bridge, which was designed by him, but later completed by somebody else. But the Cincinnati Bridge, which is known as a Roebling Bridge, was in fact designed and constructed by him. He was owning a wire road company, in fact. And just to understand the mind of a bridge engineers, you will have to have a look at the letter written by him to his fellow engineer, Elliott Jr., who was designing one of the suspension bridges at that particular point of time. And Roebling had just moved in. He says, the study of suspension bridges formed for the last few years of my residence in Europe, my favorite occupation. Let but a single bridge of the kind be put up in Philadelphia, exhibiting all the beautiful forms of the system to full advantage, and it needs no prophecy to foretell the effect with the novel and useful features will produce upon the intelligent minds of the Americans. This is the mindset or the idiosyncrasy or the bent of mind Roebling had. That is the kind of passion he had. To commemorate his memory, though he's finally settled down in America, born in Germany, German government released a stamp in his memory, as you can see here on the right hand side of the slide. Nothing can be compared to the romanticization of Robert Maillard. All of you are aware of it. He revolutionized and romanticized the use of structural reinforced concrete by his beautiful arches, a series of arches he designed and constructed. Mind you, all these people were designers and constructors. It's not just the designers. And in fact, connoisseurs of structural aestheticians like this series of art bridges to the poems of a structural structural poet. And his Salgino Tobol Bridge, as you can see here on top of that. And also it is said that Robert Maillard was always irked or irritated by the complex mathematical calculations. He was more of an imaginative engineer, where the problems can be solved by the simple mathematics rather than the complex algebra or the calculus. That kind of engineer he was. Then comes from the same tradition, Swiss tradition, another engineer, Christian Mann. And while the doctorate, honorary doctorate was awarded to him in the Stuttgart University, he was hailed to be the most creative and artistic bridge designer of our times. And in fact, he demonstrated that the bridges can be a structural art worthy of being exhibited. David Billington, gives a lot of credit to a Christian man for taking the structural design to the level of structural art. In fact, there was many discussions going on at that particular point of time among the famous engineers, whether, like the architecture of the buildings and the structural art of the bridges should be separated, and the structural art should be taught as similar to that of architecture differently for the bridges. That kind of discussion was going on. All of us know Eugene Freyssinet, and when you are talking priestessing, he is always synonymous with the priestessing. In fact, his passion for the work can be again understood by in his own words what he said. It was in 1903 that I first had the idea of consolidating concrete by priestessing. It took me 25 years of laboratory tests and much profound thought to discover the difficulties involved and way of overcoming them. Finally, in 1928, I decided that in order to realize my idea, I would devote all my efforts and all the money that I had earned in 15 years, during which I had worked for the Public Works Company for the cause of priestessing. That was the kind of passion he had, and he was doing everything hands-on. That was the kind of thing. His achievements were many. During his period, he constructed many outstanding, long-standing bridges, in fact, and he also proliferation of the priestessing technology all around the world, he did that. And in fact, he constructed the first precast segmental bridge in Lausanne, basically in France. That was way back in 1941, as you can see here. He was the inventor of precast segmental construction using the post tensioning, basically. Continuing with the tradition of the priestessing, all of you know that the Leonhard, perfected the art of the designing and construction of the priestessing in the form for long span as well as the cable stay bridges. His book, Brooklyn, or the Bridges, which talks about the design principles as well as the aesthetics, is very well known, and all of us are knowing. He's for his research as well as for his practice, he was given 6 honorary doctorates across Europe. That was the kind of proficiency Friedrich Leonhard exhibited. All of us know, again, our own Dr. Georg Slice. He was a professor as well as a structural engineer, and he was a very good friend of India. And he was a kind of engineer, who could design as well as talk about it fluently, theoretically also. And in fact, he's in a way as a sort of a founder of certain time model also, which he used extensively in the design of his cable stay bridges and the other bridges. And his contribution in India is, all of us know, is invaluable. And there are 2 more living legends. One is the Michel Horloger as well as the Santiago Calatrava. Horloger's bridge on Millau Aqueduct as well as Millau Viaduct. And that's a first multi-span cable stay bridge, one of the first multi-span cable stay bridges in the world. And also he's responsible for the first hybrid cable stay as well as the suspension bridge. That's the 3rd Bosphorus bridge, as you can see on the right-hand side. So far, till the time of perhaps Dr. Slice as well as the Michel Horloger, the form finding of the bridges was done with the principle of form finding by the flow of forces. Then came the Santiago Calatrava. He's held to be a sculptor, architect, as well as the structural engineer, and he changed the design concept. He was the penchant of his sculpture as well as the architecture could be seen in his works, even in the bridges. He has done many. And he started finding the form by forcing the flow of forces to his discretion. That is why it is called the form finding by flow, forcing the flow of forces. He's a master in it, and some of his bridges is outstanding, though it is said in the literature that his bridges were constructor's nightmare for the construction. It was always very difficult to construct. Then we know, all of us know, as in the Indian context, Dr. Subbarao is the earlier chairman and managing director of Gammon India Limited, and he introduced a lot of the pioneering techniques in India, whether it is segmental cantilever construction, precast segmental construction. In fact, he's the one who introduced to India the cable stay bridges, even the technologies like jump form and slip form, in-house design of launching girders and form travelers, post-tensioning system through the FPCC. And in the Indian context, he's one of the great bridge engineers, we can say. His contribution to the bridge engineering fraternity in India, it is, in my opinion, unmatchable. Also, in the same league, we can see Mr. C.R. Alimchandani, who started, in his own words, he was sent to India to proliferate the cause of the priestessing in South Asia, that he kept on saying. I thought that one of his best works is stretching the limits in the design as far as the construction is that of the Bhima Aqueduct. It's an aqueduct, which is circumferentially as well as the longitudinally priestess. Not only it is circumferentially longitudinally priestess, it has to carry the water later. That means it has to be waterproof, and it was done by the precast segmental construction technology. That is stretching the limits. And he is also responsible for many of the consultancies which has been working in India, and most of the very reputed consultancies like Tandon Consultancies or the Spectrum for that matter, and many more that way has got, or the offshoots, in my opinion, of the Stoop Consultants. So I think in a way, his contribution for the bridge engineering by giving many famous bridge engineers, excellent bridge engineers into country is also very invaluable, in my opinion. So coming to the last slide of mine, what made them bridge engineers par excellence, basically. I have just tried to put some of the points over here, some of the commonalities or the common characteristics which can see. All of them were bridges between the practice and research. You see any of them, especially the international stalwart which we saw, most of them were professors and also the practicing engineers. They created a bridge between the practice and research. In fact, even if you look at Dr. Subbarao as well as I think C.R. Alimchandani, to a large extent did the same thing. They were passionate about their work. They were very proud of presenting their works in the conferences and seminars, invariably participated in the international knowledge dissemination forums like FIB, IABSA, and learning from there, implemented the learning into practice in their respective countries. That's how they did that. And they were not only good structural design, but also were equally adapted to the construction engineers. Though they were the structural designers, they took a lot of interest in the construction technology, and at the end of their career or over the period, they became some sort of a construction experts also. And that's very, very important. And they believe that the civil engineer is not complete unless he soils his hands at the site. That is the belief of most of these people, if you really look at it. They have a unique perception of developing the youngsters, actually, in both design and construction. And they handpick some of their youngsters and make sure they are exposed to the international conferences as well as the symposium, where they can expose to the international world, learn the things, and they can come back and implement it in their own countries. And most of them were the leading standards and code making, if you really look at it. That is in the Indian context. Whereas the outside, they were the professors in the famous universities. And always they kept themselves updated with the technologies and material science. I think all these attributes and the characteristics are responsible for making them the bridge engineers par excellence. So with this, we have come to our today's outstanding bridge engineers, and we are here to hear them. Actually speaking, Mr. Vinay Gupta, Alok Bhaumik, as well as Umesh Rajsirke. And I've given just an introduction to the topic which we are going to discuss basically today. And what I will do is I will request Mr. Vinay Gupta, Rajsirke, as well as Alok Bhaumik in that order, invite them to give 10 to 15 minutes, some sort of a presentation of theirs, how they have been made, they have come to this status of being recognized as one of the good bridge engineers of the country, so that from that presentation of theirs, we can all benefit and we can emulate in the future to become the good bridge engineers. And I will introduce first Mr. Vinay Gupta, and he will be talking about this. And after that, I will take up Mr. Raj Shirke. Then I will introduce next to him next time. And the panel discussion can take place after the completion of all these three speakers. And we'll have a small panel discussion. After the panel discussion, if there are any questions from the audience also, the questions can be put it in the question and answer box. I'll take up the questions for discussing with the panelists. So with this, I will come to the introduction of Mr. Vinay Gupta. Vinay Gupta is, all of you know, he doesn't require the introduction, in fact. And Vinay Gupta is one of the, our president of Indian Institution of Bridge Engineers. He has, in fact, taken our Bridge Engineering Institute to the next level from the MCBD. It started with MCBD, all of you are aware of it. And not only that, he was a past president of the Indian Concrete Institute. He has been involved in many code making committees, standards and code making committees of the Bureau of Indian Standards, as well as the Indian Road Congress. He's responsible for bringing out SP 65 as well as SP 71. SP 65 is a precast segmental construction special publication. I think that is in news now because of so many accidents which has been taking place. I think Vinay Gupta has to tighten up his belt along with us also. We are there also as a subcommittee members with him. I think perhaps there's a need to again relook into that SP 61 and also the precast pretension girder. I think he had earlier brought out, and he's working on this once again. He has been a regular faculty to IIHE, CRRI, CIDC, ISDA, DPC, and many more. He has been there in most of the institutions of India, like whether it is IIS Shakti and IIB, ICI, so many to name. And apart from all this thing, he's a wonderful speaker. I can tell you that he's a wonderful speaker, and we are all very eager to hear from Vinay Gupta. Once he completes his talk, what I will do is we will take the questions, also have the panel discussion after the end of all the three speakers. And meanwhile, once he completes his speech, you can put his question of yours in the question and answer bank. We'll take it up. Vinay, I think the podium is yours, and you can start your presentation. You've got 15 minutes, and the podium, virtual podium is yours. Please take over.
Yeah, thank you, Mr. Hegde. What an excellent start with your fantastic presentation of engineering panorama of making engineers, excellent engineers of the world. I must really compliment you for this kind of a start that sets a tone to this event. Just wanted to, friends, tell you that this Mr. Hegde mentioned very well about all these great engineers. None of the great engineers that I have seen and I have sort of interacted with number of years is a person who is an excellent designer and also an excellent constructor. And this kind of a combination you get very rarely. And that's Dr. T.N. Subba Rao. And we are lucky enough to have his son, Dr. Harshavardhan Subba Rao, with us. I know Dr. T.N. Subba Rao. He was MD of a construction company doing fantastic jobs, no doubt. At the same time, when he also came into this consultancy field as Consumer Consultancy Private Limited, and we used to have interactions on the design part because my limitation is design. He used to have excellent concepts in his mind, the basic engineering, and that's engineering, really speaking. So let me just share my screen. In the meantime, also let me tell you this. I think Mr. Hegde explained about Santiago Calatrava. He's a structural engineer turned architect, and now he's doing both. So he's taking away everybody's bread and butter. All right. So here is it. I hope my screen is visible.
Yes, perfectly all right. I think you have to go up. Now it's all right. Right.
Okay, so mine is a very simple presentation. It will not have all this fanciness that we saw just now in Mr. Hegde's start, but just want to bring you to the grassroots level. as if we are fresh engineers just trying to do our finishing our graduation in civil engineering. And now we need to find our interest, which way we should go. Should we find our interest in buildings, design or construction? That's a different matter. Buildings, bridges, industrial structures, special structures of any kind, materials and testing, highway engineering. And once we decide, or once we sort of look inclined into any of these, then we have to see whether we are more interested in consultancy, government job, construction, manufacturing and supply, or project management consultancy, which is mostly the site related supervision, and surveys of any kind. There can be many types of surveys. We have to certainly find our interest and work towards that, at least in the beginning. And we have to rake ourselves up to see what is my interest. So design can be one, that you do the structural designs. Construction can be another. Every field has its own glamour. Manufacturing and supply can be another field wherein you manufacture some construction materials, special materials, mechanical products and things like that for civil engineering. It can even be like a crane. That is also for civil engineering. Project management consultancy, of course, that I said. Or you could be into contracts. That means how to make a contract document for any kind of a work, which can be a construction contract or design and construction contract or PPP, that is BOT contract. What are the crux in it? Try and understand those, follow those, and make a contract document which is hassle-free, debates-free, any contractual sort of a conflicts-free, and it gives you the best product out of it in the least possible time. When it comes to any of these, we may be interested in upper structure. We may be interested in, especially when it's bridges, we may be interested in bearings, which are between the superstructure and the pier cap substructures or whatever. We could be more interested in substructures. We could be interested in foundations or special devices, or all of these. Special devices are like expansion joints, bearings, seismic control devices, and so on and so forth. They can be isolators. But most important, as I mentioned about Dr. T.N. Subba Rao, is a structural concept. As civil engineer, we should not be only sort of computer savvy alone. Yes, computers are required, softwares are needed. But the understanding of the structural behavior, which comes from our within, is extremely important. We need to understand the behavior. Anything that we design, anything that we put on the drawing, it must be constructible. Otherwise, there can be bigger problems. If you made some designs, some drawings, and you find that even the concrete can't reach, or if you find that there are clashes in the reinforcement or in pre-stressing, or the other problems, it's not constructible, you can't lift it, you can't handle it, then also the design or whatever we do on the drawings is not a workable, complete design. At every construction stage in a bridge-like structure, the design checks are needed. Now, the construction stage design checks are so very important in bridges, they perhaps are even more important than service stage analysis and design. For example, you remember the recent collapse that has taken place in Bhagalpur, Sultanganj Bridge in Bihar. I'm not trying to say that design checks were not done, but look at that bridge, which is cable supported bridge. It's an extra dose bridge. There is many stages of construction of cantilevering and therefore joining, making the structure from isostatic to hyperstatic. At every stage, at every cable, at every segment, or even the bridges that Mr. Hegde showed, at every stage of the construction, you have to carry out a full-fledged analysis, full-fledged design, and also, of course, provide for pre-cambering in such a way that the final structure is at the required profile, horizontal or whatever it is. And after doing all this, or alongside doing all this, the structure must be economical. And for that, you have to know, or you have to slowly understand which structure would be economical in the given circumstances. unless it is termed as iconic structure where cost is not the criteria then becomes the shape, the form, the aesthetics. So just coming to my own side of it, I was not driven by anybody 40 years ago. I was just on my own. I had no, in fact, guidance from anybody to decide what to do. Going to which engineering, even during the, say, 45 years ago, when I entered the engineering itself, there was no guidance which branch I should take. Somehow I used to see things under construction, especially buildings more so at that time. And I used to take interest in those buildings. And I used to wonder why this happens, why this column, why this horizontal member, why all this flat slab, etc. These things. And it just generated an interest in civil engineering. So I did that. And after doing that, again, I did not know where to go. Somehow, I found that if I do a consultancy, I mean, that's my interest I'm talking about. And I also get an opportunity to visit the site and see how the construction is done. I was, for myself, looking more happy there. So I said, fine, let me be into a consultancy. I had an interview, which I applied for, and I got selected in the first one in Delhi itself. And I got into it. And I got so interested in the analysis and design and detailing. Now, especially detailing, because I wanted to see that detailing, how it is constructed. Because that was my interest to know that it should be constructible. Because the questioning was always there that I'm doing something on my design drawing. How will somebody be constructing it? So once I've done a design, once I've created a drawing, then I sit on the other side of the table and I'm the contractor now to construct. And I see what questions can be raised in this design and drawing and solve them now itself on the drawing, so that the questions are reduced to minimum. Not that I have to go to the site and explain my drawing to the constructors. It should be self-explanatory. That used to be the aim. Slowly, I developed understanding of pre-stressing as to how it is different from reinforced concrete and what are the other intricacies, crux in it, which need to be accounted for in terms of losses and friction, wobble, blah, 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 time-dependent losses. And of late, I would say maybe about 15, 20 years ago, or maybe 25 years ago, I got more into, not more, but substantially into bearings and special devices. These special devices, I mean, we in our company, Tandon Consultants Private Limited, would have used about 20 years ago, first time, 2003, 2004, for an NHI project, which were this STUs, shock transmission units. And then somehow some interest developed. And the bearings, I used to design each and every bit of it. That means if you have a pot bearing, then designing is bottom plate, cylinder, it's elastomer, top plate, PTFE, etc. If it's elastomeric bearing, then again the entire bearing. So various kinds of bearings I started designing, and I thought that was a very intricate field for a very small element. But this element is only about 1% of the whole cost of the bridge. Then, of course, got into some code preparation that gave me some more enthusiasm, some more boost. I started taking interest in technical specifications as to what all they should be. I prepared quality control documents. So all these things are quite interlinked, that you have specifications, you have quality control, and you question yourself as to why this should be done this way. Why not the other way? What are the merits and demerits? So when I used to visit the sites, I used to go through all these testing laboratories and see as to what they are doing and why and how. What are the controls required? So that automatically kept an interest in the field. Then, of course, I started delivering lectures. So that gave some more boost that I am at least imparting what I have collected over the last 30, 35 years. Now it's, of course, 4 decades. And, of course, joined several professional bodies. Of late, I have been the president of ICI, now the president of IIBE, and so on. Now, the advantage of civil engineering that I see in general is that everything that you do is constructed, you see it, the public sees it, whether it's a building or a bridge or a chimney or any other structure. So once you do this, it's an automatic appreciation by masses because people have seen it. They may not come openly and tell you that they liked it or not liked it, but at least they have seen it. There's nothing imaginary. Unlike some other fields where you imagine this must be happening. Here, everything is in front. You see it, you appreciate it, you like it or you dislike it, whatever it is. It gives a confidence kind of a thing. And slowly, of course, when you have reached certain stage, you receive awards, they give you further boost to the morale. Then you come to innovative structures. The world over, everybody is busy trying to construct long span bridges, cable supported bridges, suspension bridges, and so on and so forth. So within our own limitations, we also try to do so-called innovative structures in the sense that whatever you do furthermore than what you have done earlier is innovative for you. There is no global definition of innovative structure. So that's the advantage that you see all these structures, you design, you construct, you see it in front.
You are doing it 1800. It's too high a figure.
India, for that matter, is constructing about 40 kilometers of roads per day, which is perhaps the largest in the world. Per day, 40.
I
It
think,
requires automatically a large number of bridges.
Just a minute, I think, Vinay, Professor Jyoti Busari, I think, can you just put yourself in mute?
नहीं mute हो गया है.
Yeah, okay, thank you. I think
Okay.
Vinay can go ahead.
Yeah, so 40 kilometers of road per day obviously requires a large number of bridges that come in between into the roads. States like UP, Bihar, they are constructing like 500 bridges at a time. And that's a very good big number. So definitely the infrastructure development of the country is quite on a rise, absolutely on a rise. Only thing, when we are constructing a large number of structures of any kind, not only bridges, then failures also have been more. And we need to avoid these failures by various means. So we are preparing documents in our like code. Mr. Hegde mentioned SP65 for precast segmental or SP71 for pre-tension eye girders. We are building in clauses to see what all the contractors and the designers must take care in their designs and construction to see that construction stage failure, which are generally more, should not take place. So finally, it comes to capacity building. Do we have as many experts? Are you people geared to get this expertise and therefore build the capacity for this country, including manufacturing, materials, engineers, site engineers, design engineers, and the softwares, and so many things are required when we talk of our capacity building for the country, because we are building 40 kilometers of roads per day. We look for special bridges like long span, extra dose bridges, long span cable stayed bridges for larger spans, and they have to be safe under construction. There are quite a lot of them are under construction in the country. When we were trying to collect data about, I think, cable stayed bridges, which are lesser in number, we found that there were 30 over bridges, which India already has cable stayed technology. Extra dosed, maybe even more. Long cantilever construction bridges, then metro constructions are on the rise that you see all over the country. Perhaps the largest number of cities is in India where the metro construction is going on. Maybe it's not as much of length as in China or some other countries, but the number of cities that are busy with the construction of metro is perhaps the largest. About 20 over cities or something are busy constructing metros. But we need reliable material suppliers. We need reliability in every field, of course, and we are a little bit short of it, I must say, in general. There are all kinds, but yes, there are problems. Sometimes the contract documents for the construction, etc., may not be written properly. So they need to be streamlined in such a way that ambiguities and any kind of debates are reduced to bare minimum. Then I come to my last slide, education system. Everything begins from here. In my opinion, although we have some faculty members here with us in this presentation, in my opinion, the faculty needs training on bridge aspects. When I say bridge alone, in buildings, I have seen faculties more and better trained, but in bridges, on an average, the training available in the faculty is little lesser, which they need to. And I would say, in fact, I have been a member of this what is it called, course building committees, where I've always said, make bridge as a course, compulsory course. Let people learn. When they learn building, let them also learn bridges. Make site visits, take the students to site and let them realize, understand, and appreciate. And that may also create an enthusiasm in them to become civil engineer when they look at the site and they see the things happening. Then, since educators, the faculty, they taught us a lot of basic concepts. And we are into industry who are applying these concepts for implementation. We are the implementers. Now there must be an interaction between industry, that is we people, and the academics, so that the faculty as well as the students learn whatever they taught, how it has been implemented, and what they need to teach to their students. And types and concepts of bridges, because there are many kinds of bridges, we know, many kinds rather. So they have to be understood, and there can be more types that one can develop. Like somebody has developed, as Mr. Hegde talked about, cable stayed suspension bridge. So it's an hybrid. Computer, keep in mind, especially is my advice to the young engineers who are coming out of colleges. Computer should be used only as a tool, only as a calculator, which can produce the calculations very fast, but never be slave of it. Never trust the computer. Always check the results from your expectations, from your experience. Otherwise, people have made mistakes of any magnitude. All right. So thank you so much. I think I took probably a little more than my given time. So thank you. Thank you very much, and all the best to everybody.
Thank you. Thank you, Guptaji, for your wonderful exposition of your experience, and also for explaining your life journey as a bridge engineer. In the process, you have sort of explained as to what it makes to become a good bridge engineer. But we'll have a large panel discussion at the end of all these talks, and some of the questions may also come at that particular point of time. And also, we have many panelists, other panelists apart from the speakers here, like Dr. Harshavardhan Subbarao and others. And I will invite them to ask you the questions also later. And with this, I think with this, I'll come to my next speaker, Mr. Rajesh Shirke. Rajesh Shirke, yes, Rajesh Shirke is out. How come Rajesh Shirke? Yeah, yes. Okay, I will. Yeah. Raj, I will take Alok, and after that I will go ahead with you. So, Mr. Raj Shirke was scheduled to be the next speaker. Unfortunately, I think there is a problem of electricity in Vashi. By the time Alok, I think I'll have to inconvenience you. I'll have to take you out of your order and request you to come the next speaker. And I don't think Alok requires the introduction. Basically, Alok Bhaumik, again, in my opinion, is one of the consummate disseminator of knowledge in India, and structural engineering knowledge, I should put it as. And he has loads of experience of exceeding 4 decades in the design of bridges as well as the other structures. And he has been a recipient of many awards, and the latest one being the S.B. Joshi Memorial Award from COEP, College of Engineering, Pune, very prestigious one. And he's also Indian National Academy of Engineering Fellow, and that's one of the greatest recognition in the country for an engineer of any discipline, for that matter. And he's a past president of Indian Association of Structural Engineering Engineers, and from which platform even now he has been doing the very, like this, I should say that the philanthropic dissemination of knowledge, that the dissemination of knowledge is also a philanthropy, in my opinion. Those people who do not have money, perhaps I think they indulge in the dissemination of knowledge as a philanthropy. I think he's mastered that art, in my opinion. And also, he's very active in the Consulting Engineers Association of India also. And he's professional engineer, a chartered professional engineer from Institution of Engineers, and he has been in the the editorial committee, committee of many journals. One of them being IABSC, INJ IABSC journal, Bridge and Structural Engineer, where he has was a chief editor for a long time, almost 10 years, where he has taken the face of this, in my opinion, the journal to the next level itself, and it's made for the successor to make it. He had made it very difficult to maintain that level of, the journal, in my opinion. As Mr. Unai, he's also a member of various Bureau of Indian Standard as well as the Indian Road Committee committees. Especially when we are talking about the bridges, his latest contribution, we'll have to remember that he was the convener of the extra dose bridge guidelines, which was brought out recently. It has been approved and it's under the printing now. And Alok, as a bridge engineer, we are very eager to hear your journey, and also your tips to the youngsters that can be done during the perhaps the discussions that can be done. The virtual podium is yours.
Thank you.
I think
Am I audible?
Ruhi, I think we'll have to take out this slide of yours so that Alok can share the presentation. Yeah, you are audible.
Let me try and.
You have to make it
Can share your screen now. Yeah.
Is my screen visible?
visible. Yes.
Not
You have to
yet.
go. Yeah. Perfect.
Yeah, okay.
Yeah.
So thank you, Mr. Hegde. First of all, I must thank Indian Institution of Bridge Engineers giving me this opportunity to speak about a subject which is very, I'm very passionate about it. Making a bridge engineer. I have been lecturing at many places and trying to encourage young engineers to sort of come into this field of bridge engineering. So this is a subject of very much my choice. We have heard Mr. Hegde, his initial opening remarks, excellent presentation, giving a background for this topic. And thereafter, we have heard Mr. Vinay Gupta, another very good presentation, giving a complete picture of how he grew up as a bridge engineer and what should be done, what are the various fields. Excellent presentation. In my this short presentation, what I plan to give is an insight of how I grew as a bridge engineer over the last 40 plus years. And I would like to also share my thoughts on how one should approach the challenge of becoming a good bridge engineer. Just to mention that, a bridge is not just a structure that fulfills the functional requirement of crossing a river or an obstacle. That's the way many people look at. It's just like another structure. But it's not that. A bridge connects people. It has to meet the social, environmental, and cultural needs, because many times a bridge is an imposing structure in the built habitat. So it should not be treated just like any other structure as a structural engineer. People are crossing through the bridge. It should be a delight for the public when they are crossing the bridge. There should be a feel-good factor. Is what is the ultimate aim, which if the public is happy looking at the bridge, they are crossing it, then you have served the purpose of becoming a good bridge engineer. So this is the broad content of my presentation. I will take talk about a little bit about my story, not much, and then I will focus on the role of bridge engineers, why bridges are important, what sort of skill does a bridge engineer require. In the next, I will talk about the social, cultural, environmental, and physical issues that create concerns in which a bridge engineer needs to work. And with those concerns, he is successful if he can meet those challenges. the results will be appreciated by all. And the last, I will talk about the designing of bridge as a structure. I mean, this is the last in the priority, in my view. I mean, that is relatively an easy part. Once you understand the importance of a bridge, once you understand the social, cultural, and environmental context, designing of the bridge is the easier part of the work. So let me begin with my story. What you see here is my name card with a long list of credentials. Generally, I don't use these long lists in my letterhead or anywhere. There is a specific purpose for which I am showing this here. So this slide illustrates the learning path that I had gone through from my since I graduated in 1981. I passed out from Delhi University, BSc Civil Engineering. When I did my post-graduation from IIT Delhi in 1992, I was a part-time student there. At the time I was working in a consulting field. I became a life member of Indian Roads Congress in 1993, became a member of Indian Institution of Engineers India in 1995. Later in 2002, I became a fellow. I took the membership of YAPSE in 1995. I became a fellow of IAS Tructee in 2005, and I served Indian Association of Engineers as president from 2019 to 21. I took life membership of CEI in 2018. I was nominated as a fellow of the National Academy of Engineering. I consider this as one of the topmost honors that I have in 2019. I became an international professional engineer in 2019. I was nominated as a member of YABMAS, which is the International Association for Bridge Management and Safety in 2021. I became Life Fellow of Indian Geotechnical Society and a Governing Council member in 2022. And I also appeared for an exam and qualified as an FIDIC Certified Consulting Professionals in 2022. Reason I'm showing all this is to highlight the fact that if you want to grow and become a good professional who would be recognized, then you need to be continuously upgrading your skills. That is the first lesson which I want the participants to learn. You can see, I have been continuously upgrading my skills, and which has helped me immensely in the profession. All these professional associations of which I'm a member has helped me to maintain a high professional standards, which in my view is very much required by the very fact that you are following certain code of conducts which are given in these professional associations means that you are on the right track. And I think this helps you a great deal, as an engineer. Now coming to the industry experience, after graduation, I worked for about 15 years in various consulting firms. The last one being in Malaysia with a firm called HSS Integrated Sandrian Berhad. And in all these consulting organizations, I have worked, in bridges. Last 20 years, I have started on my own 20 years back with my wife as a partner. She is also a bridge engineer, civil engineer, and structural engineer. Initially, when we started, there were a lot of advices from my friends, most of them negative, saying that it's a stupid idea to start a structural engineering consultancy. There is no money. And to a large extent, maybe they are right. But I had some passion in the consulting. And despite all the advices against, I started. And I can tell you that first 5 years when I started, first 5 years were really a struggle. Thanks to my staff and also my clients that I survived. Thereafter, of course, it was enjoyable journey, and I'm still enjoying the challenges, both as a structural engineer and also as a businessman. The challenges that I'm facing day in and day out me a lot of pleasure also. It gives me a lot of satisfaction. Coming to the next section, which is why bridges are important. Let me get into this subject. Bridges are indeed important for the society. I have explained that before, because they connect people, they link communities. As a bridge engineer, we must be aware of the societal needs that the bridges fulfill. We must be sensitive to the expectations of the public from a bridge, and we need to develop skills so that these requirements can be fulfilled. It is not just sufficient to fulfill the requirement of your immediate client with the terms of reference, and if you just tick box saying that I have designed as per these terms of reference and that therefore I have done my job, that is not really bridge engineering all about. Your ultimate client is your society, the public, and therefore you need to really win the hearts and minds of the people whom you are delivering. This is to be remembered. Now, you see what this slide shows are some of the ancient bridges. One on the top left is the Pont-du-Gard bridge in France, 2,000-year-old. This bridge was built to transport water and not vehicles. At that time, 2,000 years ago, the water was available somewhere on the top of hillock, and the urbanization was happening somewhere else. They had to carry the water for the civilization to grow, and they built these aqueducts. And I don't want to go into the technical details of it, but if you really go through the technical details of construction of these aqueducts, it is a story by itself. All these masonry arch bridges were without any joint, and they have survived 2,000 years. And you can see a piece of architecture there. So bridges are not just, as I said, the connect is a structure which connects. If you really study these bridges, what you see in the bottom right is the bridges in Tripura long back earlier, which is called the the timber bridge. What do you call it? Living root bridges. So these are the ancient bridges where people have used their minds and wisdom. And what you see on the bottom left is the wire rope bridge. These are all wire rope bridges made with leaves and the tree trunks, and these have got limited life of 1 year or 2 years, and they continuously building the community. So this is the kind of history of the bridge engineering that we are talking about. They are, as I said, many of the bridges are imposing structures in our landscape. They are landmarks in some cases. They can be symbols of their location. Many cities are known by the bridges. For example, you go to Sydney and talk about Sydney Harbour Bridge. You go to San Francisco, you can't escape visiting the Golden Gate Bridge. You go to London and you definitely will be visiting as a visitor the Tower Bridge, London. You go to Venice in Italy and you will not miss Rialto Bridge, which is a bridge, arch bridge, which has got on top of that some shops. And these are very, very old, 2,000-year-old bridges, this Rialto in Venice. It's a tourist spot. Bridges, there are other bridges also which are lifelines in rural areas. And even today, there are more than 1 billion people living in the poor and rural communities around the world. And these people do not have easy access to their basic needs. For them, these bridges provide connectivity so that their children can go to school, colleges, and they can visit the health centers, etc. So as a bridge engineer, when you design a bridge, we have the duty to not just address the functional requirement. We also have a duty to make them function robust. And for example, there is a video which I wish I would like the organizers to show after this presentation, which is drawn 4-minute video by World Bank, which is recently created. I got it just yesterday. And it shows how the bridges have helped bring resilience in Uttarakhand after the 2013 floods. And that is the kind of responsibility a bridge engineer need to understand when he takes up this subject. We have seen many failures, and we have seen the failure of Bhagalpur Sultanganj Bridge. When a bridge fails, the community struggle, development stagnates in that city, particularly when a operational bridge fails. People suffer, and other than the huge economic impact that we have, a bridge, even during construction, if it fails, it will delay the project by maybe few years, 5 years, 6 years, 10 years. So the whole community struggles when the bridge fails. That may not be true when a building fails. Apart from the losses, the damage is only localized, whereas when a bridge fails, the entire community suffers. And we need to understand this. Now, coming to designing the bridge in social, environmental, and cultural context, let me talk a little bit about this. There is a need for taking into consideration the environmental factors and the societal factors. We are, as you all know, in a climate emergency today. This is a completely new paradigm where we have to think differently. It is not there in any textbook or in any codes or any standards that we have been following so far. We have to develop a new standard for us. Reducing the greenhouse gas emission, reducing the carbon footprint in bridge construction is an added challenge today for the bridge engineers. As we all know, these bridges that we are constructing, they have a very high embodied carbon, and therefore there's a great challenge that is forced upon us to reduce the carbon footprints. The bridge design considerations are also different depending upon what type of bridges we are designing for. When we are designing railway bridges, I mean, I'm not just talking about the difference in the loads. That is, of course, there. But other than that, the attention to detail also will keep changing depending upon the functionality of the bridge in environmental and the social context. For example, if you are designing the railing and other things, if it is a railway bridge where the vehicle moves at a very high speed, you don't need to pay much attention on the detail of the railing. Whereas when you are designing a pedestrian bridge where the movement of the people are slow, they will be in the railing, they will be walking along the pavement. The details of the pavement, the details of railing, the details of other details of illumination on the top of the deck are extremely important other than the structural detail. When you are designing, for example, an urban highway bridge, all the details because one can be moving on the surface level, one can be moving on the top. Each and every detail has to be looked into from the social context. These are some bridges which I think Mr. Hegde also touched upon, that we need, as a bridge engineer, you need to derive inspiration from great works done by our predecessors, our role models. And these are just few examples. One is this bridge, which is the Millau Viaduct. This is a stunning bridge in south of France, designed by not only just Michel Barluge of France, but also, I think, Neil Foster. And together, jointly, they have done this spectacular bridge, which is a spectacular synergy of architecture and engineering, as Mr. Hegde mentioned. Also, he showed this Selig-Nottobel Bridge in Switzerland, which was constructed in 1930 by Robert Maillard, and I think construction also. It's an absolute sublime, this bridge. I mean, it's a masterpiece, and even today, when tourists visit the area, this is also one of the tourist spots there. This is of relatively recent origin, constructed in 2019. This is a footbridge, Tintagel Castle in Cornwall in UK. A spectacular and historic bridge site, which recreates the bridge that existed historically from 14th to 17th century. It's a replica of that, but at a different level. I mean, if you really go into the story, it's a long story. I don't want to get into the story. But what I mean to say is, you see, you can look at the kind of effort and detail in trying to create these structures. And mind you, these are not just iconic or signature bridge structures. No, it's not that it is a signature structure, so it has to be good. There are routine as well, which has to be good. I mean, I will quickly go through some of these, bridges from which we draw a lot of inspiration. This is one in Switzerland done by Christian Men. I think Mr. Hegde mentioned about Christian Men and also his works. This is a bridge designed by Jörg Schleich, father of our friend Mike Schleich, who has been very instrumental in many of the projects. Both father and son were instrumental in, I think, several projects in India, including Vidyasagar Setu, Signature Bridge, Delhi. And this footbridge is one of his masterpiece creation. And Jörg Schleich, by the way, is not only just a passionate structural engineer. He has not only excelled in bridges, but I think he has done pioneering works in lightweight construction using tensile structures, solar energy, and name any of these and go through the work done by him. It is very, very inspiring. This is a good example where I wanted to show something different. This is a footbridge in urban setting, and if this is an award-winning bridge, of course, and it's a good example to show how the bridge detail connects so well with the pedestrians. I mean, you see, it is a part of the design that this bowstring arch bridge, the level, you can just see where of the top of the bottom chord is kept. It is intentionally kept for the pedestrians in this urban area to play leisurely, sit, gossip, and this is what is what I'm talking about, the contextual design. We have some bridges in India also which are very inspirational, and I've just showed you. But generally, unfortunately, they are few and they are far. Unfortunately, our academic institutions, engineering colleges do not teach aesthetics for the structural engineers the way it should be. And that is perhaps one reason why many of us in the profession are insensitive to aesthetics. And even if there is a cost addition of 1% or 2%, generally client would say, "Nee, let us go this one." Look at metros in Delhi. I have seen in many corridors, same corridor, 2 columns will be circular. The one, due to some reason, became rectangular, and the next one will be of a different shape. And suddenly, from a box girder, you will be converting into a eye girder. I mean, nobody is looking at the whole project in integrity as one. And this is an area where I think, as an engineer, you need to also create your own kind of area, create your own expertise, and make sure that it is aesthetic. I just give 2 examples of what you should not do. One is, of course, the famous bridge, Alamilo Bridge, which Mr. Hegde also mentioned. Is a Santiago Calatrava creation, but that structure has. When you design a bridge, you have to satisfy the requirement of cost, optimization, aesthetics, integration, environment, everything. It is not just to meet one criteria and forget about the other criteria. Alamilo Bridge, Spain is one good example where the aesthetics have been satisfied more than what is required there. And as Mr. Hegde mentioned, that the form follows the function was completely reversed. That is the trend of Santiago Calatrava. So this bridge has costed almost 5 times the normal cost of a bridge, and therefore the public there and the authorities have heavily criticized. After the post-construction, it was also a matter of criticism. But if you look at the bridge, it is one of the icon there, aesthetically very good. Look at another example which is not acceptable, is the Delhi Metro structure in Delhi. I just took 2 photographs. And this is in the heart of the urban area, and where you can see that how it is treated when you have a long span, of the height, and suddenly you have a short span. Not only that, if you see the painting is done only where the vehicles cross at the center, thinking that as if this part do not require painting. I mean, this is very insensitive. And you look at the one at the bottom. So this is a very insensitive way of, and sort of maintaining our structure from aesthetic consideration. It only shows insensibility to aesthetics. Coming to the last part of my presentation, how does a bridge engineer goes about conceptualizing and creating a structure that satisfies all the stated and the unstated requirements, which I mentioned earlier, is what I'm going to describe here very briefly. There are 4 stages of a bridge project. You first do a concept design, and then you do a preliminary design, then you carry a detailed design and a construction stage. The purpose of the conceptual design is to come up with various feasible bridge schemes, decide on one or more of the final alignment. You decide the alignment and all design, decide the broad concept for further consideration. Concept design is kind of process of form finding, as I think Mr. Hegde was mentioning, which is the most important phase of the design. And generally, it is a very experienced person who is supposed to work on the concept design. This is the initial but most crucial step in the bridge project. Mostly this is the responsibility of the DPR consultant, mostly the responsibility of the client or the feasibility consultant, and in some cases you have sometimes even that part also is given to contractor, in which case the contractor also does the conceptual design. Generally, it is not the contractor but the client and the DPR or feasibility consultant who does this. When it comes to preliminary and detailed design, that is the next stage. The purpose of preliminary design is to select the best scheme from these proposed concepts, and then to ascertain that the feasibility and constructability of the selected concept, and finally refine its detail and estimates, based on which the tenders are floated. The purpose of detailed design, of course, is to finalize all the details of the bridge structure, go into much greater detail, refined analysis, so that if it is item rate contract, then the tender document quantities and all will be much more refined. And if it is a EPC contract, then perhaps mostly I found that detailed design stage is not done to a level of satisfaction, and it is left to the EPC contractor's designer to do that. And the construction design will be much more elaborate, where each and every stages of construction will have to be analyzed in great detail, as Mr. Vinay Gupta was mentioning. And mostly in a EPC mode of contract, this is done by the contractor's design consultant. A bridge engineer needs to provide input at every stage, be it at the feasibility stage or DPR stage, and or as a contractor's designer. So if you want to be a good bridge engineer, you have to learn all these 4 stages very meticulously, and that is where the experience lies. Just an example of signature bridge, you see, I've picked from a presentation by Professor Dr. Mike Schleich. In the conceptual stage, the kind of sketch that they put is a hand-drawn. As you can see, this is what they have done. Then when it came to the preliminary design stage, a two-dimensional analysis was carried out to broadly sort of dimension the structure. Then when it came to the detailed design, there were further more details, and each and every connection and other design, detailed design. Just a symbolic way of presenting the various modes. These are the various alternative options which were studied by the designer at the time of conceptual design for the pylon shape itself. So this indicates the level of work which is required at the conceptual design stage. Not necessary that you end up with so many options for each and every project. It depends upon the type of project and the importance of the project. But you have to understand the very basic concept is that you need to study various concepts, whether it is a simple bridge or a complicated bridge or a signature bridge. You need to come out with various alternative concepts, measure weighs the pros and cons, both from the cost, from aesthetics and all aspects, prepare a matrix, give them some weightage, and finally choose a solution which is best suited to that particular structure. So in conclusion, I would like to say that bridge design today is a multidisciplinary task. All different expertise is needed when we build a bridge. It is not only just a structure which is to be designed with steel and concrete, and you have to only optimize the cost. No, that is not so. Today, we are in a climate emergency. We have to talk about, we have to take care of the climate. It is the politics that we need to worry about. It is the environment that we need to worry about. And it is the natural resources that gets recycled that we need to worry about. All this comprises of a bridge design activity. And it's not necessary that you have to be expert of everything. No, but you need to be, if you want to take a lead as a bridge engineer, then you need to understand each and everything. You may not be expert. You may be taking the expertise of one particular aspect of this, but in other aspects, you should have fairly good knowledge so that you can be in the decision-making table, taking a lead position. Bridge engineers have to adopt an integrated multidisciplinary approach, pooling the knowledge of all special experts into one unit and creating this, the structure as we call bridge. So last slide, making of a bridge engineer would require developing a passion for bridges. There is a need for continuous professional development to keep yourself updated with the latest technological and scientific development. Get involved with professional associations like IAS Structi, IIB, MI Structi, CAI, Institution of Engineers, and the likes. Connect with the societal needs, need to be sensitive to social, cultural, and environmental needs of the society. Innovation is vital in bridge engineering. It should be in DNA of every bridge engineer. One can't be a good bridge engineer if she isn't wanting to innovate. I mean, you just don't follow the conventions and be happy. You need, every structure is unique, every bridge is unique, and you can find something new and learn something new in that. But only a word of caution is that innovation shall be done from a position of knowledge and strength. It's not a good idea to do innovation with half knowledge. That will be dangerous because safety is a prime concern here. Thank you very much. With that, I have come
Thank
to the conclusion of my session. I think I have taken a little more time. What is allotted, but
Yeah, thank you, Alok. I think though you have taken time, it has been a fascinating journey as a bridge engineer. I can see that. And also you have explained as to what is the inspiration which, inspires you to, like you have shown the examples of Calatrava, you have shown the examples of so many good engineers like Slice and Christian Mann and Robert Mylott. And that's what the inspiration is all about. And also in a way you have explain the design process also, which is a good design process which has to be followed. And we'll take up all these things at the end of the Mr. Umesh Rajashirke's talk as a panel discussions. If the time permits that, we'll have a long discussions over there. And with this, I invite our next speaker, Mr. Umesh Rajashirke. And Umesh Rajashirke is a first generation entrepreneur. In fact, is similar to that of Alok Bhowmik too. He had worked in Stoop and he was one of the prominent engineers of Stoop Consultants. As I told that the Stoop has produced some of the finest bridge engineers, not only the bridge engineers, structural engineers in this country, and his consultancy firm, also the Spectrum, I should say, is one of the offshoots of Stoop Consultants. Now, Raj Shirke is a postgraduate from the VJTI, and also he has done his, he is a graduate from VJTI and done his post-graduation from IIT Madras. And he has been involved in the cable stay bridges and long span cantilever bridges. And in addition to that, he's also involved in the design of the nuclear containment structures, natural depth cooling towers, etc. And he's also involved. He's one of the persons who regularly attends international FIB as well as the IABSC symposiums and conferences, I should say. And our country has very few designers who has done the multi-span cable supported bridges. I think Raj Shirke is one of the very few multi-supported cable stay bridges, bridge designer in this country. With this small introduction, Shirke, that I'll hand over this podium so that you can take over. You have 10 minutes, if it's possible for you to complete.
Actually, what has happened, Hegdeji,
Yes.
that all of three of you
Yeah.
has already spoken most of the things which I had covered in my presentation. So
Yes.
while you were speaking, I have deleted many of slides in my presentation.
Fine, fine.
So that will make the things. I may take hardly 10 minutes, 5 to 10 minutes. I will
Fine.
not go through all the things which all of had talked earlier. Okay, so yeah, so this is again the bridges built for transportation, commerce, and again for war. And during many war, the attempt is to destroy the bridges to win the war. So that is another aspect of the bridge. We should mention. It is a necessary for civilization to exist. And again, as all of you have said, these are the iconic structures. Many cities are identified by the bridges they have in their cities. And hence it is obviously the most exciting career in civil engineering. One should have a passion to build that career and should get thrilled after seeing these magnificent bridges. And the most important aspect or the fascinating thing is to you deal directly with the nature. That is what excitement I find. You have to deal with the gravity, you have to deal with the wind, the light that cyclone has making the noise in the last 2-3 days. Then you have to design for earthquake, moving loads, cyclic loads, fatigue. So that makes this particular structures very interesting for any engineer. And then you have to play with the material, whether it is a masonry, concrete, steel, or timber. And you have to play with their material properties, their response to the loads, the long-term, short-term, creep, shrinkage, fatigue, whatever it is. So we have to learn those, what are the properties are there, and you have to play with this material. Again, you have to play with another uncertainty, that is a foundation. There are a number of foundations like the open foundation for this Thane Creek Bridge, pile foundations for many of the bridges, and the well foundation. So you have to choose the appropriate foundation. So that is again a very important decisions we make. Again, you have to play with a number of structural systems, as what Alok or you have said in detail. So in the concept and planning stage, you have to choose that appropriate structural system. You have to see the constructability, the cost and economics of that particular solution. Then along with that, you should know what are the various accessories we use in the building these bridges, like a precision system, or say the bearings or expansion joints. Then obviously the construction methods, whether it's a precast or a cast in situ, balance cantilevering, and so many. And along with that, as an engineer, you should be very proficient with the project management, whether it is in a design office or at a site. So so that is one of the important aspects of being a bridge engineer. Again, what Alok and all of you have said, the social aspect, aesthetics, environmental consequences, and so on. So I will not repeat here. So making a bridge engineer, see what I feel, the bridge engineer is not some special kind of engineer. He is mainly a civil engineer. Among the civil engineers, there are a few structural engineers or construction engineers. And from that, some people do the design of the bridges. So actually, it is a subset of a entire, that is the civil engineering, then the structural engineering, then the bridge engineers. And that doesn't mean that these bridge engineers don't do any other structures. In fact, to become a competent bridge engineer, first of all, you should be a competent civil engineer. Then you should be a competent structural engineer, and then the bridge engineer. So being a civil engineer, you should know about the geotechnical, hydraulics, surveys, traffic, geometry, project management, and legal, contractual aspects, etc. There are the structural engineers. Definitely, you should be knowing how the forces are flowing, loads, their response of the structures to those loads, the material, their behavior with the long-term, short-term, etc. The design philosophy, whether it is deterministic, probabilistic, etc. And with all these basics used for the particular bridge, you should know what are the various construction methods are possible, or you can invent your own. Then how that particular structure is sensitive to the specifics like traffic loads, wind, earthquake, etc. So all these things makes the competent bridge engineer. And once you are a competent structural engineer, so obviously you can design many other structures like what we do here, the natural rock cooling towers, tall chimneys, or stadiums, or any industrial structure, and so on. So any good engineer can be a good bridge engineer, and he should know all the aspects of the engineering. I want to differ from what Vinay has told, that interest in a superstructure, substructure. I don't think so. It is that kind of a bifurcation. The good engineer should know all aspects of the particular project, that including legal, contract, project management, and so on. So this is what I wanted to discuss in detail. And the next is basically it is a profession. It is a professional practice, and many times governed by the code of codes like IRC, AASHTO, Euro, and so on. In some countries they are a legal document, some countries they are just a guidelines. So, but all these codes or standards, they are prepared by the professional engineers. So that is one of the tasks as a bridge engineer or a structural engineer we should perform. And being a profession, to make a good bridge engineer, it needs an internship. It is necessary to work with experienced bridge engineers, at least for initial few years. And that is very, very important as being a profession. And obviously, as all of you told, it is a teamwork, it is a collaboration of all the experts in the field. And this role of a professional societies, as what Alok has mentioned in his career path, so that is a very important aspect he told. The professional bodies like institution, Indian Institute of Bridge Engineers, or IABSC, or ISTRUCT, or international association like FIB, AIC, etc. They play a quite big role in developing this particular profession. And to make the use of this profession societies, we should all of young engineers should actively get involved in this professional bodies, professional societies. So that's all. That's what I wanted to say. So thank you.
Thank you. Thank you, Umesh. That was a very concise and very incisive presentation, I should say. And you have given a, like what it takes to become a very good bridge engineer. And in the process, you have
Yes.
also explained, it's very important for the people to participate in the professional bodies activities. That's one of the important aspects. What I will do is before taking the panel discussions, I just want to make a small sort of an announcement about our forthcoming event. That is, the Institution of Bridge Engineers is coming out with a Bridge 2023. That's
It is it's supposed to be a curtain raiser.
Yes,
So you have to
yeah.
give the idea.
Yeah. This is one of the, I think you people can see the screen over here. All of you can see perhaps.
Yes.
And this is one of the very mega event, normally yearly event. Institution of Bridge Engineers normally hold it. Last time it was held in Pune, and this time the topic is very, very interesting, and I should say exciting. This is new frontiers in bridge engineering, and all the subject which has been chosen is a real frontiers, as you can see here. The resilient bridges, carbon neutrality in the bridge engineering, design for constructability, including the temporary structures, advanced analysis and design of bridges, digital technologies in bridge engineering, designing for the avoidance of failure, novel material and technologies. And on the final day, it's a 2 days event. We'll be having some sort of a panel discussion similar to that of what we're having on mega infrastructure projects. You can see the kind of speakers we have. We'll have again Mr. Vinay Gupta, Alok Bhaumik, Atul Bobe, Raj Shetke, and some of the very, very important speakers speaking on a very relative topical topics like the sustainability. Most of this is related to the sustainability, as you can see here. And those people who are attending this panel discussion today, or the special lecture today, I request all of you to participate in this event, a very important event of Institution of Bridge Engineers without fail. And the registration is already open. I think you should start registering for this event. Very important event it is. So with this, I'll come back to my the earlier. Are you able to? Yes, that is.
May I add, Mr. Hegde, one line?
Yes.
To
Please.
Bridge 2023, which is being organized in Hyderabad, the 2-day event. It's a flagship event of IIB. The first one was started in 2018 in Lucknow.
Yeah.
After in 2019, Bridge 2019 in Patna. Following 2 events they took place necessarily on online mode. And thereafter in 2022, as Mr. Hegde mentioned, it was in Pune. It was a grand success. And now we want to make a grand success out of Bridge 2023 in Hyderabad. So please come all, join and encourage the organizers. Thank you.
Thank you very much. We had a very interesting 3 talks from the 3 experts in bridge engineering, and we also have some eminent bridge engineers among the panelists. Dr. Harshavardhan Subbarao is there. I think before starting the panel discussion, in fact, Harsha, I think you got to say something on the presentations which have been made so far, and also you have got some questions to the speakers, so that you can stimulate the panel discussion by way of asking the question itself. Harsha, if you have got some views as well as the questions to the panelists, you can start your panel discussion. I would like to start from you.
Right. Thanks, Venkat. I think this has been a brilliantly compared event and exceptional speakers, and there's very little for me to add. But I'll tell you a little story about myself. We've all been telling our stories. So I'll tell you a little story about myself. I'm a third generation civil engineer. The pyramid that you saw, I'm part of that actual pyramid. I reached the apex of that pyramid much later in my life. But I was very lucky. My grandfather was a civil engineer. He became one of the first architects in India because there were no architects, and he became a fellow of the American Institute of Architects, and a wonderful practice in an elite place called MG Road in Bangalore, a big office. But my father didn't work with him. My father left he did his engineering in Bangalore, left Bangalore and came to Bombay and joined a company called Gammon India. He was posted elsewhere in Travancore Mills and so on for some time. And then he came here. I'm telling you the story of my generations, my generational story. And then he came to Bombay and got posted to the design office of Gammon India, where he rose up to become its MD. And all that Venkat told you about, Venkat has worked with him too. All of us have worked with him. And yes, everyone needs a mentor, and he was definitely my mentor in bridge engineering. So father then branched out and developed a passion for all kinds of structures, but he took distinction, I would say, in the art and science of bridge engineering. There he excelled. I mean, internationally and nationally, he excelled, and it was a passion. Right from my young childhood, my grandfather's office, and then my father's work. And then when he became MD, I was quite young. And the chief engineer and MD of the company, I was quite young. So all my holidays were spent at Doda Bridge or at Kolaghat Chimney or at Kandong Dam, or name it, we would be there, or going down to, I remember one event, we were at Darjeeling, and the Teesta Bridge, where it had to be built. The Akar Bridge at Teesta was a thought in his mind, and he had spoken to Jorg Schleich about how we can do it. And let's take a bold shot and try and do it. So father and me and what was his name? Singh, I forget his name. Sardaji gentlemen, in four-wheel drive, we drove down on that dirt road 4 hours to meet the Chogyal. He was the king. It was a kingdom there. Sikkim was a kingdom. We went to meet the Chogyal, and very readily, my father sold him all this thing about, beautiful bridge, this, that, like a pagoda shape, all nonsense. And he fell for it, and he paid for it, and we built Akar Bridge. So that was India's first cable-stayed bridge. I used to work there with Jorg Schleich, and we had 2-3 German fellows there. And I remember staying in that camp. And this is how I evolved emotionally as a bridge engineer. That's what I'm sharing with you. I'm not talking to you about the big bridges that I do, none of that. So this kindled in me a passion, because here were people in the midst of nothing, and the cables for the cable stay actually were spun at site from wires. So that was the level of challenge which I saw happening around me. And this passion for bridge engineering, which had already been kindled, took deep roots. So I went through my engineering. I did my master's at the Institute of Science. Then I did another master's at, that was by research. Then I worked, I went to Ann Arbor, Michigan, got another master's in pre-stressed concrete, I specialized. Then I got an Imperial College, I got a PhD in which I did in steel structures. So I tried to expose myself in different materials, different types of forms. Then I taught at Imperial College, and that gave me a lot of confidence. I'm telling you about my story, about how things evolved and how I grew. And then I worked in London for some time. It was on tension-like platforms, or North Sea tension-like platforms, and hydrodynamic loading, and very difficult to build structures, then flexible risers and so on. So very specialized stuff, fully nonlinear and all that. I was away from bridges for some time. Though my PhD was on bridge engineering and steel structures, I was away for bridges at some time, though I taught at Imperial. Then I came back with some reluctance. I got married in London. I came back with some reluctance to India. And at that time, my father left Gammon India for some issues. And we started Construm about 35 years ago, father and son. I learned from him. I used to learn, and he never used a computer. He never used a computer. He would get data from a computer if he wanted. He knew how to use it, and always innovation. So I grew up with this idea that there is innovation. Everything we've got to do differently. We've got to try something new. Don't be scared. So these were my mentors, and you've heard enough about all that, so I won't bore you with that. But look, at the end of the day, what drives you? Why a bridge? Why do you choose a bridge to express yourself? After all, it is an expression of me. When I design it, it is me. I'm in it. I live with it. I live in it. And I'm part of it. I'm part of its making. And when I walk over it or when I drive over it, I feel joy and pride when it's finished. But it has to be safe. It has to be functional. It has to be aesthetic. And today, it has to be in the paradigm of sustainability. So we are also growing. As bridge engineers, there's this idea that we keep evolving and growing. We are not static. That's another challenge. The new materials are just ultra high performance concrete, a new material with which bridges are being built, just a new area. Even till today, we don't have, for example, say fatigue loading in our bridges duly addressed to the level that we need. We are still struggling. We are still getting there. But that's the challenge. As a bridge engineer, you face a lot of challenges. If you like challenge, as was said earlier, you have passion. And if you have a good mentor, like all of us had good mentors, I must admit that. And it expressed itself even 3 generations. Akkar Bridge was first generation, father and York Slice. Second generation, again, father and York Slice on second Howrah Bridge, cable stay. And the third cable stay, as I would like to call it, signature bridge, 2 generations, and then the next generation, Mike Slice and me. So it's a story. It's a story. If you have passion, it'll stay with you. You'll grow with it. I grew with the art and science of bridge engineering. It gives me a lot of value. It gives me a lot of ethics. It drives me in many, many ways other than just engineering. And if you have that first to grow, if you have an agenda for growth, bridge engineering can surely be a part of it and drive you. And there's nothing better than joining IIB. There's nothing better than joining IIBSC or any of these fora where you can meet some of the great people, read some of the works, participate in webinars, events and discussions, join working groups and grow as a bridge engineer. That's my message. That's my personal story and that's my message. Regarding the second part, Venkat, now that the emotional part is over, now coming to the second part of the discussions, I'd like to ask, let's start with Raj because he had lesser time. Raj, when you started Spectrum, what were the challenges you faced? When you decided to strike out on your own, how did you muster up the courage and what took you in that path?
Yeah, you're
muted.
You are muted. Shirke, you are muted.
Yeah.
Yeah.
It was very simple. I got very bored in Stoke. Nothing. It was so stable job. I got fed up and decided to come out, have some destabilization, and started. That's all. Nothing specific in the mind.
Anyway, on a lighter note, that's on a lighter note, but you did probably have a...
No, but that is how it was. And Alim Chandra told me that you come back whenever you find that thing is boring.
No, I think,
particular...
I take the cue from, I think let us start the panel discussion. Continuing with the question of Dr. Harshavardhan Subbarao, you see the Stoop was producing that time some of the outstanding structural engineers as well as the bridge engineers, apart from even Gammon was, if you to be honest, has been producing. And what was the culture and what was the environment which was there, which was encouraging to produce so many, good engineers in Stoop at that particular point of time?
So let me tell you, I joined Stoop immediately after my graduation, that is in 87. And that time, stalwarts, apart from Mr. Alim Chandani, there were Mr. N. Raghavan, who did a Thane Creek Bridge. Then there was a VL Deshpande, Jogolegar obviously was there. Then there was PV Tantri. He was a very good construction engineer. Has got a lot of technology for the enabling structures. Then there was a Sarangadhar. Then obviously at my level, PGV, then Sistarian, and so many. So it was a very, very conducive environment. And I used to freak in that office. And really was, and it was a very open atmosphere. You can go to anybody, ask questions, they will ready to help you. Again, the kind of a library Stoop was having was a fabulous. Mr. R. Jayaraman, he was also another good engineer. Used to maintain that particular library. There used to be weekly seminars on current topics, on current projects. Whatever the people read in the magazine, journals, they used to share with the other in those seminars or technical talk. Then there used to be a site visits, very regular. And we used to visit number of sites around Mumbai, like a Thane Creek Bridge and Vasai Creek and so many. And again, the consultancy business or practices were very, very different, obviously. All this manual drafting, manual calculations, 286 or 386 kind of machines, very plain P grid and P frame kind of programs, and so on. But there used to be a lot of interaction with the seniors. They used to handhold you, give a lot of freedom in the design, taking the decisions, and that's how we grew in that particular environment.
Yeah,
Hegde sir, can I come in here?
yeah, no, no, yeah. I think you can. You have to. Yeah.
Yeah, so let me also mention that I'm also a stupide. I mean,
Yeah.
I also worked in Stoop,
Yes.
for about 5-6 years of my initial career from 82 to 86.
Today and moderator are access to.
Yeah,
Yeah.
let me share.
Did I watch you there in the school? Yeah.
So honestly, I'm very fortunate that the first 5 years after my graduation, I have worked in an environment where there was huge scope to learn. And Stoop has given me that platform. Initially, when I graduated in 81, first 6 months I worked with Gilcon under Dr. V.K. Raina.
Mhm.
So I have been very fortunate that, my initial bosses were a source of inspiration for me. I worked for Dr. V.K. Raina, but of course for only a short period of 6 months. But that exposure in bridges helped me when I joined in 82 January. It helped me to get all the big jobs, Chambal Bridge at Kota, when I was just having 6 months of experience, because I only had the experience of bridges at my level. And I worked under Mr. M.K. Chatterjee. I think one of the best bridge engineer I have, a person who is, he's not, no, very few people know about Mr. M.K. Chatterjee, but I think he was an excellent engineer, bridge engineer. And then in Stoop, particularly, the environment in Delhi office, Vinay also was a part of the Stoop Delhi. And you see, as a young engineer, we had a lot of elbow room. And we had a lot of, senior people to give advice as and when we require. You see, this is a basic fundamental difference where Stoop used to operate the way and the other consultants. Here, we were given a lot of freedom, and there is somebody like Mr. Rangarajan used to be in Stoop, who would not interfere unless you ask him to interfere, but he's having a close watch on us, And when Mr. M.K. Chatterjee also was there, he would call us maybe end of the day, maybe at 5 o'clock, he will call each and every engineer for 15 minutes, and he will know only what you have done, what you have not done, and how you have done, whether you are in the right track. That's it. That was the kind of interaction. And I tell you, this environment helped us to grow. I remember specifically one project, just I will take 1 minute. There was a project, of captive power plant, 5 into 120 megawatt captive power plant project, where Stoop Delhi took the job of preparing fabrication drawing for power plant. The idea of getting the job was to get exposure on power plants. The idea was not to earn money out of this project. And this project was assigned to me at that time. I was hardly having 2 years experience, with zero experience on preparation of fabrication drawing. Then they asked one specialist, a very senior level person called Mr. Bijurkar from Mumbai. He came to Delhi. He spent 2 days with me. He came here only to train me. And 2 days he spent with me. He gave me all the inputs, all the books, literature, And then that is how we started on that project, and that project we completed in about a year's time. Initially, BHEL was very upset with us. How can you do a project with a young engineer like Mr. Bhavik? But then subsequently, end of the project, they gave a lot of appreciation to Stu. So I think this environment created was very helpful. Thank you.
Yeah, I
Yeah.
think that's well said, and yeah, that's well said. I think that brings to the next question of ours, like this, the environment and the culture in an organization certainly, grows the young engineers to their next level. That's always the case. And all of you highlighted on the importance of participating in the professional bodies, code making committees, conferences, symposiums, and participating and always constantly keeping yourself updated with the latest developments as well as the technologies. And all of you had the opportunities, like Vinay had the opportunity, Alok had the opportunity, as well as our Rajesh Irke and Harshavardhan Subbarao also had an opportunity. But these days, nowadays, especially in the multinational organizations, consultancy organization, I call it as a time logging, budgeted hours, billing and collection culture. That's the culture. And they don't have an opportunity to participate in the professional bodies. In fact, that is considered to be, like wasting time. The official time is wasted. And also, it is not encouraged much. Under such circumstances, if the youngsters are working, how can they cope up? How can they change the situation? Because this culture of billing and collection and time logging and budgeted hours culture certainly stifle the growth of any engineer, structural engineer for that matter, to become the prominent engineers we have been discussing so far. So outstanding engineers over the world. Also, your own experiences says, can this be changed? Or how these people who are working in this multinational organization, multinational consultancies can, really come out of this sort of a shackles and start participating in the professional bodies for their own, for them to become a very good bridge engineers. Any views from any of the panelists? I would like to hear.
Yeah. So may I?
Yeah.
So I think you see these problems should not be looked at as a problem, in my view.
Mhm.
You see, I think as an engineer, when you start your career, I think there is a need for us to inculcate this feeling that you at end of the day, end of your career, when you look back, you have to see whether how did you rise in the profession, and whether you feel repentant ki somewhere I was supposed to do this, I did not do. So the way forward is, in my view, whichever organization you are working in, whatever may be the culture of that organization, you have to have your own set goal, which may be a little different from the organizations where you are working. If you have a budgeted hour of working, that does not mean that after the budgeted hour you are not supposed to work. You may not be budgeting it, but your career, when you are your career is important for you. So for your own professional development, you need to maybe do much more than what your budgeted time allocates. I know one of my junior colleague in US, and the girl told me that, when I'm working there, my budgeted hour is 8 hours, but I work for about 12 hours, and I don't budget that 4 hours which I'm working at home, because if I use that 4 hours, then it is a discredit to me. But at the same time, I realize that those 8 hours is not sufficient for me to complete the work which I have been assigned. So, end of the day, in my view, your career, your profession is your main prime objective. If you are very focused, then you can break this barrier. It is not an issue. That, you see, these are issues for those who work like engineer clerk. They are not issues for those who are working in the engineering to sort of excel.
Okay, I think that's
Finally, it is a profession.
yeah.
See, finally, it is a profession and not a routine 9 to 5 job. So, to develop your profession, you have to put your own effort. And I don't think so. MNCs are discouraging their engineers to not to participate. It's up to engineers. They can definitely go tell their management. They can convince them and participate in various activities. So it is possible, not that difficult.
Okay, Vinay, you have some views on this?
Well, I think elaborating on what Ms. Alok Bhaumik said, there is definitely a challenge all of us who are running a company are facing, that people have lost sort of flair for a futuristic thinking. They only think for today, and especially the young lot. And they want to get into this MNC. Of course, I don't want to discourage MNCs or demean MNCs, but into a culture where they work like factory workers. When we say factory workers, you are given a task, you are told a method, you are giving the time, given the time, you produce, go back home, 9 to 5, and you're out. And maybe comfortable air-conditioned environment, which of course nowadays more or less all of us have. So, but no sense of responsibility, no sense of learning engineering, doing more of a mechanical work, that you're given the way of the method of working, you have a software, input, output, deliver and go home. And understanding of the structure. And today, let me tell you, with the advent of these computers and cell phone and so many tools that you have, in a cell phone, you have everything in your hand. It's a torch, it's a camera, it's a calculator, it's everything. A scientific calculator. You don't want to memorize anything. Memory is getting lost. Today also, I spoke to some of my engineers in the office. I said, you don't even remember this? We just said, what is the value? Oh, we don't, I mean, yeah, let me check on my computer. So the memory, which we are losing day by day, concept that we are losing day by day, and of course, flair for engineering. If it's finance, you have all the flair, but if it's engineering, you're losing the flair. So this, I think, is going in a very divergent direction to my feeling. And that's a challenge we are facing as managers.
So what it transpires from the discussion is, it is a initiative which is taken by the engineers themselves, rather than, the culture around, if one wants to excel and one wants to become a bridge engineer, of the excellence, par excellence, I think perhaps it is necessary for the engineers themselves to take an initiative when we are in certain cultural environment like this. I think that's what it ultimately boils down to. Now,
Hegde Saab, just I just want to quote one very good example of myself. When I was in, just a story, small story.
Yeah.
When I was in CES, Consulting Engineering Services, there were 500 engineers. And in 1988, I remember, 1988, I'm talking about, when there was a international conference organized by IABSE in Bangalore. That conference was attended by Fritz Leonhard, Jörg Schleich, and all these followers. And I, as a young engineer, hardly 1 year experience in CES, I was wanting to attend that particular conference, but I was 100% sure that nobody will nominate me. Because there are 500 people, I just joined, though the CES will nominate only 2 or 3 senior most people for attending that conference. But I was bent upon attending that. In the evening, one evening, I went to Mr. S.S. Chakravarti, his chamber, sought appointment. Those days, getting appointment of the MD was also a very tough thing. And I told him, look, I would like to attend this conference. If it is sponsored by CES, I will be happy. If it is not sponsored by CES, I will be on my own. Please give me just permission to attend. And Mr. Chakravarti was completely surprised, because nobody in the past had given this kind of opinion. So he was embarrassed that if he says that, no, I will not sponsor, that also he could not do. So finally says, I will sponsor you, but you have to go by train only. The other people will go by air, but you being a young engineer, you have to travel by train. That was a 36 hours train from Delhi to Bangalore. And I did that and I attended. So what I'm trying to say is that, you have to also take a little bit of initiative on your own.
Yeah,
So-
that's well said. I think that's well said. Yeah, yeah,
Mr. Hegde, give me a minute.
yeah.
I want to tell Alok a contrast today. Contrast today is that people do want to attend and they do attend. They get a holiday from the office. They're very interested in how the lunch was and how the things and rest of it, they're not bothered on an average.
So I think that's the reason we have been conducting this particular panel discussions to understand what it makes makes to become a good bridge engineers. We have discussed about so many inspirational bridge engineers over here. I hope that will inspire the people who are listening, especially the youngsters.
Anyway, sir, we have to welcome Mr. Taude. Taude has joined the discussions.
Yeah.
Taude sahib,
Dr. Saab,
welcome.
Yeah,
From owners.
Yeah.
Mr.
thank you.
Yeah.
Can I?
Yeah.
Hegde
Please.
sir,
Yeah. Please, Taude sir.
so all you work in the Stoof in the beginning are associated. My indirect association with Stoof from 83 to 90. My office was very near to Edwin Chamber where CMD and all directors were
Oh.
sitting. I was just here. And my boss was brother-in-law Chandar Alim Chandani. So we had a close access with Stoof, and day to day all the structural engineers of Stoofs were my colleagues, not colleague bosses, that because I was very young officer, joined MOST in 83. So I used to go at least 2 times a day to have a cold drink in Stoof office. My boss was very fascinating to have a cold drink, and there was no facility in government office. You understand, even not a fridge to have a cold water. 83 का आप ऑफिस जान लीजिए, मुंबई का नो फ्रीज. So हम चाय पीने, कॉफी पीने Stoof में चले जाते थे. Then we used to have one of the director in the Stoof. So I have 7 to 8 years close association with Stoof, indirect way. And some of the bridges were being designed by these Stoofs. One Tapi bridge in near Dhulia. It's a long bridge. So that time Mr. Phadke, Umesh, you may be knowing Mr. Phadke was doing the design. He was in charge of the.
We,
Umesh,
फड़के नहीं थे, फड़के
Phadke was doing that design.
देशपांडे और
वो
okay.
Tapi काफी लंबा bridge था. So
हाँ.
we had, my duty was to just associate with him so that when the term of approval was done, it was easy for us to approve the design. So I just want to tell that I have a 8 years long indirect association with Stoof. Then when I joined in 83, there was some problem in Kasheli Bridge near. Kasheli Bridge was constructed by Gammon. There was grouting problems. If I think you may all have heard about the grouting problem. Cable could not be properly grouted and there are a lot of blockades. So senior officers from ministry was coming, one like us that day, Mr. Sitaraman, Mr. Sitaraman was in charge of the bridge. If you have any association with MORTS that day, 83, 84, like that, some of the bridges, there were bridge directorate MOST. Have you heard about the bridge directorate? There was bridge directorate and road directorate. So some good eminent like Mr. Koshi, Mr. Edi Narayan, M.K. Mukherjee, then Mr. Chakrabarti, Ms. Sitaraman. There were few stalwarts from the bridge directorate. I think your early days you could have associated with them.
Yes.
And being in Bombay, I was posted in Bombay, work in Bombay for about 20 years, long bridges being constructed in near Bombay. I was very fortunate to have associated with not only my bosses, but I have a very close 1 or 2 years association with Dr. Subbarao also. He's Harsha. So I have a lot of fascination for Harsha. 83 to 85, every time when senior man was from Delhi was coming, my duty was to receive them, take to the bridge. Then Dr. Subbarao would come along our discussions. So I was inclined to bridge engineering since my joining in 83. But unfortunately, I remain in the field. My throughout career, I work in the field. I could not get chance to work in the corporate office or head office in Delhi to be associated in design. But I'm construction side, I'm a bridge engineer. So making up the bridge engineers. So I'm not a structural engineer or design engineer, but I'm a bridge engineer. Associated very long bridges, about 7 kilometer long elevated structure we have constructed during my tenure. We had some problem. Then we referred this problem to Alok and Tandon Saab. Alok, do you remember my problem? There was some unbalancing problem.
Yes,
The bridge
yes,
was
I do
designed by
remember,
the
sir.
L&T. Then you had given
L&T.
so there was pressure from L&T for resolving the issue. They wanted completion certificate. My independent engineer was reluctant to give. Then construction engineer, I found a way. I referred matter to Tandon Saab and Alok. We had a meeting near NHI's head office in one hotel for 2-3 hours. Then very gladly accepted our request. And after receiving the request, I resolved the issue. I accepted that report and we closed that chapter. Now the bridge is taken over by NHI. There are no problem. There were earlier problems reported by the independent engineers. These are long bridge. Then we have again the collapse of Mandvi Bridge. I joined. Then the inquiry committee was looking at Jahangir. That is, Jagirdar was a judge looking after that. The judge was appointed to look after the collapse of the Mandvi Bridge in Goa. I was a young officer directed to attend the hearings with the documents, judicial inquiry, and young AEE, I think I was AEE in 83, 85. I used to go with the files during 83 to 90. So going to judicial inquiry with files, again, lot of deliberation. One of our colleague, my senior boss, Mr. Ellis Bassi, was a design engineer. That time design was approved in MOST. Bridge was constructed, I think, by Gammon. Then design was done by Gammon and design was approved by Mr. Ellis Bassi as a chief engineer. In committee, they appointed me as just a supporting officer to committee from technical. Then I used to go with the old files. A lot of Goa engineers were known to me due to my participation with them, and a lot of files, proper maintained files, I was carrying to the commissions. Then I think that Jagirdar committee passed stricture against the design approval engineer, like in Ellis Bassi. Stricture passed directly against the chief engineer of MOST who approved the design. And it was a jolt on the career. I think then after some times, the Mr. Ellis Bassi passed away by heart attack like that. And it was a murmur that due to this court verdict against him, he had a heart attack. It was an old story, 87, 88 like that. So making a bridge engineer, I'm a bridge engineer by construction site. And today's presentation and today's experience of all my 4 colleagues, Hegde Saab, Vinay Gupta Saab, Alok, and Umesh. And during my tenure as a chairman of IBSC, all the structural engineers from India, construction side, I had a very close association with everybody.
Yes.
Very close association during last 14 to 18 is a long tenure. And it was a era of Mr. Gadkari also. Mr. Gadkari also wanted something innovation in the bridge design. He always talked about submerged bridges, then long span bridges, submerged bridges. Then I think in my tenure, we did discuss on the submerged bridges, but we could not approve any submerged bridge at least in India. I think something is being done in West Bengal, if I'm not mistaken. Yeah. And we had one small session in Nagpur, IABSC event also on the submerged bridges. So I have very close association with all the bridge engineers, good bridge engineers, excellent bridge engineer, Dr. C.R. Ali Chandar. CR, we used to call him Chandar, being his brother-in-law was not a CR but Chandar. He's popularly being called in on family members Chandar. Then Dr. Subbarao, Harsha's father. My senior bosses, I named Ninan Koshi to MK Mukherjee and all this. And today's generation, Tandon sir, and all my colleagues today sitting in the panel. So I'm very fortunate. So I considered a fortunate bridge engineer by having some construction experience, not in design. So that is equally bridge engineer needs and design, supervision and construction administrative experience also. So that I just wanted to share my personal experience. Thank you very much. Thank you.
Thavde Saab, that has been a fascinating journey as a bridge engineer from the government side, we didn't
Yeah,
have a
yeah.
speaker from the government side. It is very well, like you have been hobnobbing with some of the stalwarts of the bridge engineering fraternity, what I can see.
Yeah,
And,
thank you.
And one more thing I just
Yeah.
want to add, I think Tawade Saab's tenure as chairman IABAC, ING IABAC,
Yeah.
I found it to be the best. I mean, the maximum number of activities took place
During
during
that
his
period,
tenure.
yes,
Yes.
yeah,
Right,
exactly.
Thank you, sir. Thank you very much.
So I
Yes,
think
thank
what we can do is, I think as we are running short of the time, we are already exceeded the time limit. We'll take couple of questions which is there in the question and answer bank. That is one
Okay,
question. Yeah,
I just seek to be excused because I had to go all the way back home. There's a meeting at 8:30, which I
please.
attend. So
Yeah.
thank you all and become bridge engineers. It's very worthy profession.
Yeah, we'll
It's a
meet.
very worthy and satisfying
23rd.
profession.
Yeah.
On that note, excuse me.
Yeah. There is a question
you.
from Samir Malwankar, and it's a very topical question he's asking. It's very, I don't know who is going to take from the panel. Can we avoid failures of bridges by only making good engineers? That's a question, I think.
That is the only. That
you
is the only way.
uh,
That is the only way to avoid the failure.
No, I
Because the
may I?
capacity.
Yeah.
Yeah, please, Alok.
Yeah. So see, you making a good bridge engineer or a good structural engineer would mitigate the risk of having failures. I mean, one cannot guarantee that if you are a good bridge engineer, you will avoid failure, because bridge failure can take place due to a number of reasons where you are only one of the many players. But if you are a good bridge engineer and you are designing a bridge, then the risk of failure is reduced to a great extent.
Alok, the definition of a bridge engineer is not pertaining only to the design. It pertains to other aspects also. Even the construction engineer, the project manager, project director, even the QA, QC, all are bridge engineers. So that good bridge engineer, it means all the engineers associated with that project. So if everybody augments their capacity, their know-how, knowledge, that will definitely reduce the probability of failure at a site.
Agreed.
Vinay.
Hegde, may I say something?
Yeah, please.
See, when we say a good engineer, a good bridge engineer, there is a vast difference between bridge engineer and a good bridge engineer. It's not a small difference, just the word good. What happens is that a good bridge engineer thinks about every aspect of it. And when he catches something, he corrects it. Like, for example, there have been umpteen number of cases where the structure was just floating on free bearings. It was supposed to be connected to a fixed structure which is laterally restrained, but it was floating on free bearings, and nobody, or probably the people connected there, did not think that during this stage, presently, during construction in certain stages, the structure is floating and the structure fell down. So when I say good bridge engineer means, as engineer, you think that every stage is very, very important especially in a bridge.
Correct.
Construction stages are very important. And there are many such examples. This is only one of them I'm saying. How you place, how you stabilize, or somebody may put trestles to support a cast of concrete. And they will take the vertical loads, or other pipes, they'll take the vertical loads. But do we think about the second part of it? That is the buckling, the deflections, the wind, the earthquake. During the construction also they do take place. So a good engineer will keep questioning himself to think about aspects of stability as we talk of construction. And of course, we have design aspect, no doubt, as Mr. Rajashekar said. Design is not the only thing, but yes, there are design aspects like the concrete strength, the compressive stress, tensile strength, and the reinforcement. All those things are there. You can get those from the softwares, no doubt. But once you get a value from software, you presume it's wrong and verify.
Right.
Yeah.
All these things bridge engineer will normally reduce, as Mr. Bhaumik rightly said, the number of accidents or number of failures to minimum.
Right.
I hope all three.
Hegde Saab, it is at 7:25. You have to wind up in another 5-10 minutes.
All three of you have, I hope, have together satisfied Mr. Samir Malwankar for his question. I will take a last question because I think there are a lot of questions here, but I will
Yeah.
not be able to take all the questions. I think one very interesting, request is there from one Mr. Rushikesh Kasar. Hello, sir. I'm a BTech structural engineering student from Sanjeevani College of Engineering, Kopargaon, Maharashtra. My goal is to become a bridge engineer. Please guide. I think one of you panelists, I think if you can guide him, I'll be very happy about it. He's a very enthusiastic bridge engineer student. He wants to become a good bridge engineer. And how can he become a bridge engineer? He's asking the question.
Well,
Hello? Yeah, Alok or Vinay, any one of you, please.
Yeah, so I think what you are seeing here are 4 entrepreneurs representing 4 different consulting fields. If you have a bent of mind for design, I mean, you can contact any one of us and we will be very happy to guide you. If you are inclined to join a construction company, there are many, we can guide you also there. So it depends. First, you need to understand at this stage, if you can, that what is your bent of mind? Are you a field person or are you more comfortable in consulting? Even if you are not able to, many a times, for example, when I was young, I was not able to even decide that. But my advice there also is that once you join a firm, whatever you are doing, you put your entire energy and focus in that. Because this passion is also not something which is God gifted. You have to develop passion. If you study more deeply in a subject, you automatically with time develop passion into it, and it is a self-driven. Then it is a self-driving thing. But first you have to work very hard in the initial period, whether you are in construction or in design, and develop interest so that you can go much deeper and wider.
Yeah. I'm going to take a last question, but this question may, open a Pandora box. I'm a little bit afraid, but I would request one of the panelists to answer this question in very brief, so that we can conclude this today's event. The question is, what do you think is the reason for having so many bridge failures during construction itself in India? It doesn't happen so frequently in other countries. I said it is like opening a Pandora box, but if one of the panelists can give a brief answer due to the shortage of the time, I would like one of you to take up this question, please.
2-line answer.
Yeah, yes.
Bridge failure does not normally take place by anyone's mistake. It usually takes place by the mistake of the designer, the consultant or whatever, as well as a constructor. Combined together, there could be a reason for failure. Of course, it can be due to one also, but in most of the cases I have seen is because of 2 different, 2 agencies involved causing this failure. So each one of us have to do our job. But your question was that they failed during construction. Now, it's been a general, that I've investigated several failures, is that the attention that is paid by all stakeholders, which are the constructors and the designers, the attention that is paid during construction aspects has been lesser. We think it's all temporary. Forget it. We are only worried about service stage. This has been broadly the reason, but there are a lot of intricacies, a lot of one-on cases one can discuss. And we have been having conferences, workshops organized by NAHEI through IAHE all over the country, only to enlighten the people how as to the failures can be avoided, with giving case studies and all that. So
yeah. I think
one line answer.
Yes.
Lack of safety culture in India is the prime reason for most of the failures. It is, there are error of intent, there are error of concept, but mostly in India, we are not learning from our failures. We are not, all reactions comes only knee-jerk, temporary, and after 15 days, it is business as usual. Whether it is a railway bridge, or it is a highway bridge, or anything, or it's a building structure, irrespective. So it is a lack of safety culture in India, which is what is killing us.
In nutshell, I would say trusting the Almighty too much. Nothing, kuch nahi ho, chal.
Okay, I think if Basant Kumar, who has asked the question, is hearing, I request him to, like buy ING IABSC journal, that's the Bridge and Structural Engineer Journal, which is bringing out a March issue of 2023, which is dedicated to this structural failures in India. It will give a lot of insight into the understanding of the structural failures, especially the bridge failures. It talks about the bridge failures, where the guest editor is Mr. Vinay Gupta. I suggest to Mr. Basant Kumar, you please buy that book, buy that journal. I think it will be very handy for you to understand why so many structures, bridges are failing. So with this, though there was one video which was given, very important video which was given by Alok. Alok, I think, I'm sorry that we will not be able to play that. It would have been very helpful. And also the normal practice in IIBE is to give a vote of thanks, and the vote of thanks was supposed to be given by Ruhi Agarwal. Ruhi, I think today I will give the vote of thanks very briefly to all the people here. I request your permission to do that. I request you to permission, permission to do so because of the shortage of time. And it has been a fascinating discussion we had today, and it was very enlightening to me. And really, I enjoyed moderating this particular session of institution of IIB special lecture. And I thank all the speakers, Vinay Gupta, Alok Bhaumik, as well as Raj Shirke, for very enlightening speak, and also the suggestions to the youngsters and others as to what it takes to become a good bridge engineer. And I take this opportunity to thank the organizers of IIB also for giving me an opportunity to moderate this event. With this, with the permission of all the speakers and panelists and the participants, I declare this today's session closed. Thank you very much.
Thank you, Hegde Saab.
Thank you,
Excellent moderation
Hegde ji.
by you.
Yeah.
Thank you very much.
Yes, sir.
Good time and
Thank you.
Thank you all. Thank you, sir.
Thank you, Rohit.
Thank you, Rohit. Bye. Bye.